We are continuing to talk about counting methods, and in this recording we're going to start with permutations. Permutations are commonly called arrangements. So when you're asked how many permutations of n objects taken are at a time are there, what they're asking for is the number of arrangements of those n objects when you select simply r of them and arrange them. So notice that order is important in the case of a permutation. When working with permutations, repetitions are not allowed. So remember again, when repetitions are allowed, we must use the fundamental counting principle. And let me highlight that. When repetitions are allowed, we must use the fundamental counting principle. Okay, but when they're not allowed, then that is when we want to use permutations. Now first I have some formulas. These are permutations. These formulas are for permutations when all items are different. So permutations of n objects taken r at a time, and I don't know if your eyesight is as bad as mine, looks like this. And we read it as permutations of n objects taken r at a time. The way we calculate it is we put n factorial divided by the quantity n minus r factorial. So for example, permutations of 9 objects taken 4 at a time is 9 factorial over the quantity 9 minus 4 factorial. Well, 9 minus 4, we want to do the parentheses first. That's 5. So we have 9 factorial over 5 factorial. 9 factorial means we multiply 9, 8, 7, all the way down to 1. 5 factorial means we multiply 5, 4, 3, 2, and 1. So eventually, in the top, I get down to 5, 4, 3, 2, 1. In the denominator, I also have 5, 4, 3, 2, 1. I can cancel those out. Multiplying 9 times 8 times 7 times 6, I get 3024. Okay, permutations of 10 objects taken 0 at a time, it's 10 factorial over 10 minus 0 factorial, and simplifying 10 minus 0, I get another 10. So 10 factorial over 10 factorial is simply a 1. So the question, when should permutations be used? Order is important. We want to make sure that order is important if we're going to do a permutation. Repetitions are not allowed. So those are the two qualifications for using the permutation formula. Now we have a second formula that's used when n objects are alike. You have n items and you have a certain portion of them, n sub 1, n sub 2, and so forth, that are alike. What we do in that case is we take n factorial and divide by the number of alike items. So for example, if we're considering how many permutations there are in the letter statistics, and notice I've used all uppercase, so some of the letters look alike. What we do first is count the number of letters in statistics: 4, 5, 6, 7, 8, 9, 10. That goes in the numerator as a factorial. Okay, now count what's alike. It has 1, 2, 3 S's. And let's see, 1, 2, 3 T's. And what else do we have? Let's see, we have 1, 2 I's. And I believe that's it. So we want to take 10 factorial divided by 3 factorial is 6. 3 times 2 times 1. 2 factorial is 2. So it's actually 10 factorial divided by 72 if we multiply that out. So I'm going to use my calculator now. Okay, 10 factorial. Get the answer to that, and I want to divide by 72. So I get 50,400. So that's the formula when we have n items alike. Our last counting method is called combinations. Combinations are equivalent to subsets, and in combinations, order is not important. So that's how we identify it. Order is not important. Repetitions, again, are not allowed in this particular case. So combinations are used when order is not important and repetitions are not allowed. So basically what we're looking at here will be subsets. And our formula is similar, and again, let me write this a little bit bigger. Combinations of n objects taken r at a time. You'll notice that this part of the formula is the same, and that includes that little factorial there, is the same as the permutations formula. What happens is we divide by an additional factor of r factorial. So you can see we'll have fewer combinations than we do permutations. So as we look at our examples, combinations of 7 taken 5 at a time, 7 factorial over the quantity 7 minus 5 factorial times 5 factorial. And you'll notice what I do. I simplify 7 minus 5 as a 2 factorial. Okay, and so now I have 5 factorial, so I stop at 5 factorial so I can cancel those out. 7 times 6 times 5 times 4 times 3 times 2 times 1. I can cancel those out. So I'm going to get 42 over 2, which gives us a 21. Okay, combinations of 10 taken 3 at a time would be 10 factorial over 10 minus 3, the quantity factorial, and then 3 times 3 factorial. So what I'm going to do is stop at, since this is a 7 factorial, in the numerator I'll stop at 7 factorial, so I can cancel. And 3 will go into 9 3 times. 2 will go into 10 5 times. So we have 15 times 8, which is 120 for our answer there. So again, with combinations, order is not important and repetitions are not allowed. And let me show you one of these on the calculator. What you want to do is enter the 10, go to Math and Probability, and you'll notice that permutations appears as number 2 and combinations appears as number 3. I'm going to do combinations since that's what we're looking at here. So I press number 3 and then I enter the number 3 and I press enter and I get the 120. And we'll go over this in a little more detail when we get to our sample problems that we have. Okay. Guidelines for selecting a counting method. If selected items can be repeated, we want to use the fundamental counting principle. If the selected items cannot be repeated and order is important, we use permutations. If the selected items cannot be repeated and order is not important, we use combinations. Okay, and I described the steps on the calculator. And so what I want you to do is pause the recording and try to do these on the calculator. Once you have finished the 5, then I'll ask you to restart the recording so we can take a look at them. Okay, I'm assuming that you have done these, and what I want to do right now is I'm going to go ahead and open up my calculator simulator so that we can do this with the calculator simulator this time, so you can actually see the keystrokes that I'll be using. And from now on, I think you'll find the TI-8384 Plus, whichever one you're using, is almost a lifesaver when it comes to... Okay, let me see if I can move my window. I know there's a way to do it because I've done it. There we go. Okay, I got it. I think I've got it set so you can see all of my keystrokes. Alright, so we're starting with number 1. We want to do permutations of 18 taken 6 at a time. Okay, so I want to quit, second, quit. Okay, so 18, math, we want probabilities. I usually go the left way, so I'm straight there. Permutations is number 2, and taken 6 at a time, and then I press enter. Alright, so I'm getting 13,366,080. 13,366,080. Okay, so hopefully you got that one right. Alright, let's look at our number 2. We have permutations of 30 taken 8 at a time. So let's get the permutations of 30 taken 8 at a time. So 30, I want to go to math, PRB, it's number 2, I want 8. Okay, now notice what's happening here. Sometimes you're going to get scientific notation. So this means 2.35, etc., times 10 to the 11th, which is equivalent to saying that you're going to have to move this decimal point 11 places to the right if you want to write it in decimal format rather than scientific format. So be aware that the calculator will jump over into scientific notation, and the exponent part, the power of 10, is always after the E. Okay, hopefully you got that one done correctly. Alright, combinations of 12 taken 5 at a time. We're going to enter the 12. We're going to go to math, probability. Combinations is number 3. Taken, how many at a time? I've forgotten already. 5. Okay, taken 5 at a time, and we enter, we get 792. Alright, combinations of 20 taken 3 at a time. So 20, math, we want to go to probability. Whoops, not 2. Let me go back. I need a 3 at a time. Okay. So 1,140. Okay, how many ways can the letters in the word mathematics be arranged? So we have to count the letters. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So we have 11 factorial over, let's see, we have 2 M's. So we took care of the 2 M's. We have 2 A's. We have 2 T's. And I think that's it. So it's going to be 11 factorial. Each of these 2 factorials are 2, 2 factorials are 2. So 2 times 2 is 4, times another 2 is 8. So let's go to our, and I'm going to go to probability. I want number 4. Get that answer. Divide it by 8. So it looks like I get 4,989,600. Okay, hopefully you have enough now to move on to the sample problems for section 4-6.